Hi, this short video is an introduction to how to calculate the call price with Black Scholes. I think we went through this our last class meeting before we had to stop face to face, but let's review. So you have these six inputs, and we need numbers for these six to calculate the Black Scholes price. And once we have those six inputs, we can calculate D1 and D2 first. This is the Black-Scholes equation here, but it's best to do this one first and then D2, and then we're kind of work from the inside out. So if we have this slide just sort of describes that in the old days, if you were using tables to get your ends, and then you could get a negative number by this sort of thing. But we don't need that anymore because we have Excel to calculate the n of d1 and the n of d2 using the function normsdist. Suppose we have these inputs rather. Stock price 50, X is 45, and so on. We should be able to see that the call price that we should get should be more than 5 because the intrinsic value of this option is already 5, and the value of a call is the intrinsic value plus a time value. And also, the value of the call that you get using the Black-Scholes formula will not deviate very much from the market call. It's funny that way. It's a lot of things in life are not that way, and this is one of those exceptions where the theoretical model actually matches the market price for a number of structural reasons. So the volatility is a bit high, so maybe it'll be a large time value. It's got to be somewhere between 5 and 6, one would think, something like that. Definitely not less than 5, right? So we're doing something fancy that will give us a result that we can almost foresee. And if we just plug in those inputs from the previous slide into here, right? Not 25, but 0.25, not 6, but 0.06, etc. You get these numbers for D1 and D2. You can easily try this at home, right? I'm going a little bit quick because we do 5-minute videos, and I might double back and go into more depth on some of these things. And this is a table that we don't need anymore because we have Excel. Everyone has Excel at home. And so then you can get the n of D1s in Excel using equals norms dist. Don't forget the S in the middle of these numbers. And do try this at home. And we get this is our n of d1 and this is our n of d2. We can go back and plug those things in. There's a little minus sign here. Make sure you notice that here. Sometimes these e to the minus 0.02 times 0.25 will be really close to e to the 0, right? Which is just going to be close to 1. And here you see it's 0.995, But here's our answer for the call, which is 5.985, and that certainly matches what we expected, right? It had to be more than 5. It is actually almost close to 6, so there's quite a hefty time value, maybe due to the large volatility of 25%. The volatility of the market's more like 20%, but I'm just kind of guessing here. Okay. Let's look at how you get that in Excel, right? Let's see if I move myself out of the way. Here's like if you have a number here and you want to get normsdist of it. See the function in Excel? I just referenced the A2 cell. These were the rounded numbers to the, excuse my clock, to what we just did and so on.